I'm your host, Jeremy Begley. Today's episode is one I've been looking forward to for a long time because we're joined by Wes Davis from ACCA, the Air Conditioning Contractors of America. If you've ever wondered who's behind many of the standards, codes, and technical guidance that shape how our industry designs and installs HVAC systems, there's a good chance Wes has had a hand in it. But this isn't just a conversation about standards. We're talking about where HVAC design is headed. We dive into the biggest overhaul of Manual J in years, why the survey process of Manual J is becoming more important than ever, how AI and APIs can fundamentally change the way load calculations are performed, and what that means for contractors, software developers, and the future of HVAC design. Along the way, we go down a few ADHD rabbit trails because that's what we do. We get into heat pumps, electrification, quality installation, commissioning, humidity, real-world design challenges, why calculations alone don't make a designer, and how ACCA is evolving programs like quality installation to help contractors prove, not just promise, aka verify, wink wink, they're doing good quality work. If you're a contractor, designer, HVAC educator, energy rater, or simply someone who wants to understand where the industry is going over the next decade, this is an episode you don't want to miss. So grab a notebook because there's a lot of nuggets packed into this one. Let's jump into my conversation with Wes Davis from ACCA. Hey everybody, welcome back to the HVAC ADHD Vodcast. I'm your host, Jeremy Begley. Today I have a super special guest, Wes Davis from ACCA. He's here to talk about the future of ACCA, all things ACCA and all things future and all things current initiatives and whatever else good stuff we get into. We tend to deviate a lot. We're both jump around guys. So without further ado, Wes, go ahead and for those that may not know, go ahead and introduce yourself and what you do and how you fit in here.
Absolutely. And Wes Davis with the Air Conditioning Contractors of America. Been there for a number of years, started out working primarily in our codes efforts, codes interactions, helping develop the code requirements for HVAC system installations, etc., and then standards development. And we launched a new effort around 2010 to recognize quality contractors in support of Energy Star. And then there was a shift at ACCA and some leadership changed and some people moved around. And I was the last Indian in the ring. And so I've been lucky enough to work with some really great guys at ACCA and elsewhere, yourself included, to further the industry. And still work on codes with David Bixby, still work on standards with Kevin Powell, still work in education and content development with Ed and Matt, Ed Jonawak and Matt Akins, and still try to promote quality installation with Brian Feeney and contractor accreditation with Sean Tolbert. And just to narrow it a little bit, I could talk about the technical aspects, all of the membership and communications and marketing, government relations. There's a lot going on at ACCA, and I'm going to stay in my lane here, but I'm happy to talk about all of it.
Absolutely. Yeah, I know there's been a lot going on, especially with all the refrigerant change and the back and forth between the government and what efficiency standards make sense and everything like that. Anybody that follows ACCA's newsletter knows that you guys got your hand in mostly all of that policy stuff. And usually you're the fair middle trying to make sure that the contractors, get a fair shake, and also too that the administration is able to achieve whatever goals they're trying to achieve within reason sometimes, and sometimes it's not within reason. So that's why someone like ACCA is definitely necessary. I mean, we want to focus a little bit on the education piece, if that makes sense. Like
Absolutely,
we as a company, we do HVAC design and we teach commissioning, and we have a product called Verified that actually, if the customer pays for it, requires a verified commissioning of the system to prove that our design and the design intent was met and the design is performing as required. So that's sort of like our world. And so like I know a lot of people that listen to this are probably, I know one, we'll just jump right into it. One burning question is Manual J's up for its, 5-year annual review? Is that every 5 years? I got that right?
It's
5-year annual.
No, it's actually been longer than that.
Yeah, I know, but that is the expected cycle is 5 years though, right?
Every
usually
5 years, typically, as an American national standard, you're expected to revise, reaffirm, or withdraw the standard. And we are in the process of doing a fairly major overhaul of Manual J. And we've got some other big projects running in parallel, which we can certainly chat about.
Well, let's do that. But first, let's say Manual J. Tell us give us something juicy, man. You're here on the HVAC ADHD Vodcast. In your mind, what's going to surprise people about the changes that are coming up?
Boy, it's a great question. I don't know if it's going to be a shock, but the big change is the focus on the survey. So at one time, Manual J was this thick, and you could do a load calculation on the back of a 2x6 with a crayon, right? You could look around, measure, look up some things in a book. You could eventually do the math yourself. And some people did, and then some software companies said, hey, you know what? We'll do that for you. And so there was a migration towards companies like Rightsoft, who built a DOS version in 2006 on the second day of the job. 96. Second day of the job, that's one of the things I was exposed to, was doing a load calculation on this DOS system. And as software progressed, Manual J progressed too, and it went from being a very thin manual to a very thick manual with a lot of examples, a lot of discussion, a lot of illustrations, a lot more data to support doing a more accurate, more rigorous load calculation. And so with all this new information and knowing that computers were doing the math, no one's doing this by hand anymore, we saw that there was a need. All right, let's let the software take care of the calculations. Let's focus on what data needs to be collected. And so we sat down with a number of folks this last summer and really dove into what's Appendix 5 right now. So it's already in Manual J, but extracting out those data points that every technician, whoever is in the house, what measurements need to be taken, what things need to be considered, what defaults can be used, and trying to quantify that so that we can provide a basic list to a contractor or a software vendor who says, okay, here's the data being collected, and they can create an input or a user interface that will help collect that data, maybe bake in some of those defaults like your windows, blinds at 45 degrees, light color. So you drive around any neighborhood and look at windows, that's what you're going to see. Unless it's the big picture frame window, and if it's a purpose-built daylight window, well, then you designate that. Getting a little deep here, but the point is that trying to help contractors do a better job knowing what they need to collect when they're in the field.
So what's that look like in the new version of Manual J?
It's a big, long list. That's what standards are there for, right? Is a great big, long list. And there's going to be still the Appendix 5, which will have illustrations and examples, and we'll have discussion and all of that. Hank did a great job of presenting the calculations that need to be performed, but it was sort of spread throughout the standard. And some of it was even in what was classified as an informative section. And so we want to consolidate that, have a nice, clean list, description of what calculations need to be done, so that future software developers don't have to hunt and peck. They can go straight to the point. So I think those are the two biggest things with the paper version of Manual J that are going to take effect this next time.
I like to focus on the survey. It's important, and I think that it's more important now with the advent of the LIDAR technology and all these ones that make LIDAR, and then there's some other that's not LIDAR, but it's the same basic concept. You can use a cell phone to walk to a house and measure it. And that takes the onus away of the measurement, which was one of the biggest time-consuming pieces of the Manual J process. Talking about the survey, like we have a workflow that we've developed and we've continued to develop called permanent load reduction, where you use the survey, to use your guys' terminology, the survey per portion of the Manual J to, if you're doing it right, if you're doing the survey right and you're collecting the data points that you spoke of, then you should be seeing things that have extra value to it beyond just the Manual J compliance. And so, our workflow teaches how to use those aha moments from a building science perspective and put them into a proposal and make money off of them, and maybe affect the general KPIs of the company down the road because you take away some of the things that aren't system related by just recognizing them right up front when you're doing the load calculation. So I really like that because there's been like some of the marketing of some of these softwares has been like, hey, we got this AI thing that will get you these great defaults. And I think we both know there's enough wiggle room in equipment sizing right now where there's defaults are probably going to, in an emergency situation, get you where you need to go. But ACCA has always been based on that detailed survey like that. Even in current versions of Manual J, it says it's a garbage in, garbage out proposition, and you need to have the most accurate representation of the house that you're building, that you're creating the load for. So like that is all great stuff that's going on there. And also too, we're moving into an age where all these data points matter more than ever. You know what I mean? Like it is a data driven era that we're moving into, especially with all the AI stuff. And so the more precise that your data input points are, the more value you have in that data in many different ways, lots of it beyond the scope of what we can even get into in this 1 hour session that we're doing here. But there's just immense value into getting that stuff right up front. And I love that you guys are like pointing it out and saying, hey, this is the way that we should do it. And also too, you're not prescribing a workflow. So people can get that data however it makes sense for them to collect it, as long as it all goes into the calculation at the end. So, you know, that is another great way that you guys are doing that. And I think were you saying that you may be open, and I don't know, I'm saying this from memory, but did you tell me that heat balance and something else?
The radiant time series.
Yeah, radiant time series. So you guys are going to consider that as a methodology now, or what's that all about?
That's a great one. One of the points I wanted to make to the things you said is there are great tools. So for existing homes, there's some great tools to help you collect that data. But if I'm a brand new guy and I've got a set of plans, what's the information I need? And if I don't know the installation schedule, the window schedule, or I don't have that information, I need to go back to the builder or the homeowner or somebody to say, in order to give you an accurate load calculation, I need this information. So heat balance and radiant time series. The Manual J is built primarily on CLTD, the cooling load temperature difference, and the cooling load factor, as it says in the beginning of Manual J. So heat balance considers a number of other equations. Radiant time series does something very similar, and they're also looking at the loads throughout the day. Manual J says, what's my peak load? So we've got a date when it's really hot and the sun is at peak impact. And in the winter, we're at an early morning when it's the coldest and we've got no solar gain. So we're taking sort of a good rigorous look at what's the potential load on the house. We're making some assumptions about wind, what's reasonable to expect, etc. So with radiant time series and heat balance, there's a whole different set of equations. And so the trick at the moment is, how do I know the right answer? So if Jeremy says, I've got a new heat balance calculation process, great. Do I compare that to the CLTD value? Is it another heat balance calculation? And if Jeremy's got one and Bob's got another, and we've got different answers, who's right or who's closer to right, or how do we help dial it in? So it's a whole new evaluation, a whole new set of issues to be considered. But the aspects of looking at the loads throughout the day, a 24-hour load calculation has got huge impacts for talking about, especially for zoning and delivering more comfort.
Yeah, thermal comfort. It's easier to consider thermal comfort by its pure definition when you're doing that calculation versus a static peak load calculation, for sure. No doubt about it. So being able to, so the thing I guess I hear you saying, or I think I hear you saying, is you're trying to create a reasonable variance between the three, where it's like, if this one is this at this and this one's at this, how much off or how much closer should they be to each other to be considered a reasonable comparison? Because methodologies, of course, there's going to be some differences, but I would think in there somewhere is a medium ground where you're like, okay, this has to be the load for the house no matter what, or else how can we use three different calculations? You know?
And that's it. What's the right answer? And then how close to that right answer does Jeremy's program need to be, or Bob's program? And Jeremy may be dead on and Bob's not All right, Bob, why not? Let's take a look at that. And that's what we do with every software review. Here's a sample home with all the specifications. What's the load for this house? All right, now let's break it down. What's the load for the windows? And what's the load for the doors, the walls, ceilings, floors, infiltration, the whole 9 yards. And if we're aligned all the way through, it's a pass. If we're not, what's your math? Let me see your formula. What did you consider? You're missing this, or, oh, you interpolated this, but you interpolated it a different way. Whatever the case may be, we try to look at all of those things and identify where the differences are, why they're there, and then make adjustments as necessary.
And then along with that, I guess there's some assembly updates and things like that, like small house cleaning things inside the standard itself where, I know from using it, there's some outdated assemblies, there's some things that don't exist really anymore, and there's some things that we do now that aren't in there too as well, so like.
I think this might be a good segue to another topic you wanted to kick around, and that was a project that we're going to do with the DOE, Department of Energy. The National Lab of the Rockies, Scott Horowitz is working on essentially a two-part process. And I think there's going to be some spin-off things that we're going to try and glean or extract in addition. But primarily the intent is to do a sensitivity analysis. Which elements from all those data points matter? Which matter the most? Can we get rid of some of them? Do we really need to dial it in this much on insulation or this much on infiltration or whatever the case may be? But we can start to look for ways that we can streamline or simplify the load calculation procedure. And then to the extent that impacts the data that needs to be collected, making it easier, streamlining the process, then that's what we want. At the end of the day, we want people to have a solid foundation upon which to build their system, and that starts with a good load calculation. And so understanding what those loads are so I can pick the right pieces of equipment to meet those loads and then distribute that as best for the house.
Yeah, the load calculation I like that you said foundation, because literally that's how I teach it to everybody. I have guys come to me and say, hey, I got a moisture problem. What's your process for evaluating? And I say, do a load calculation. Like, you start there, because if you do it right, and I followed up by saying, no, do a load calculation, like detailed load calculation, because just doing that is going to expose so much about what's going on in the building. You might be able to identify the problem right then and there from doing the load calculation. That has to be the foundational step for everything. I think that it is a good thing that you guys are taking the time to figure out what really matters the most and what matters maybe not as much and things like that. And I think as we get down the road with AI, there's going to be some kind of situation that exists where AI would be able to determine if it's right for this situation, what's the right data point for this particular situation, because even inside a particular situation, some data points matter more than others, even inside the load calculation, depending on where the extremities of the load show up and stuff like that. So there's a lot that can be done using that load calculation, as long as we keep the foundation of it sound. So I love that. Right. That is your guys' focus, for sure.
Absolutely.
So that, along with that study, go ahead. Tell us the rest. I mean, there's more to it, right?
I'm hoping to work with National Lab of the Rockies and Scott for those new building processes or new construction types. I'm almost positive offset framing was not properly addressed or accounted for. And so to the extent you do have offset framing and better insulation and thermal value, attic temperatures based on roof color and insulation and et cetera, dialing that in tighter. But taking advantage of all the research that they've done, updates of which they're aware, working collaboratively to expand. And again, I think this is a behind the scenes part, much like the math of the calculations. It's all the data, the tables that are in Manual J now, updating those as necessary so that we've got better, more accurate, more current building procedures available and baked in for selection.
And then is this the same initiative that's turning it into the API eventually, or is this connected or different or what?
The Pacific Northwest National Lab will build, once this calculation engine is built, there will be a application program interface, I believe is the term, an API, that will allow users to feed data into that calculation engine, and then it'll spit out the answer and say, here's your loads based on the information provided. And so this will be an open API. If you want to invest the time and effort to build your own calculation engine, you are welcome to do so. We want to support that. We want to provide you with the information you'll need. If you want to just build the user interface and tie into the API and use this approved calculation engine, which will be updated and modified as new research comes out or as new building materials go through the ASTM evaluation process, or as more information is provided and we understand what the thermal characteristics of that building component are reflected in this calculation procedure, it'll save on updates to the paper version of Manual J, which, again, I think as technology evolves, we're moving more to what's the data that needs to be collected and then handing that off to someone so that it can be calculated and turned into the information we need to select equipment and install that.
Yeah, and I think one thing that the API, the whole API thing does is let a lot of little guys that know a little bit about programming create their own little dashboard and use Manual J in a way that's totally approved, but also totally works for what they are trying to achieve. So I love that there's that open sourceness to it, especially in the age that we're in, where if you know a little bit of something and you have a good idea, you could create what you need. And with you guys supporting it, say, hey, we're going to give you the right answer no matter what. Do your thing. That's totally awesome, for sure.
As you know, getting the right answer depends a lot on that data you collect up front.
Garbage in, garbage out.
And so that has sparked some conversation about what will that look like after this tool is made available. And I think that to the extent that someone wants to build their own interface, that's not going to be a problem. But I think ACCA is going to shift away from saying, Jeremy, did you get the math right? Now we're going to be more interested in that user interface. What are those data points that you're collecting? What are the defaults that are baked in? Are they visible? Are they modifiable? Can you change the wind, the default wind value, summer and winter? If you say, I live in the plains, I've got a much higher wind than what this default value is, can I change that? And the answer is yes, you can. But that needs to be called out so that a code official or some other energy efficiency program that's evaluating your load calculations says, why did you use 20 miles an hour as your wind value for the load calc? Or something less. I'm going to use 5 miles an hour in the winter instead of 15. Why did you do that? Well, that's what the wind does in my region, in my area. Okay, and well, that brings your load way down because the driver for infiltration has dropped. So now your load's much smaller. I love smaller loads. I love load reduction. All of those things are going to be evaluated as part of the new process. And so we still want to have a way to call out software tools that are compliant with the Manual J process and the Manual J intent to, as much as we can, improve that garbage in, garbage out aspect.
That's an interesting conversation that you're creating here. Like, are you saying that there may be some more QA on load inputs than you have right now? A heavier hand, so to speak, from ACCA on what's going into these? Because that's one problem. I mean, honestly, it's a huge problem. We fight against it with code officials. We fight against it with green building programs. We fight against it with all of it. I've made good money over the years creating design review programs for people that just don't understand Manual J, but yet they're set up to police Manual J, for lack of a better word. You know what I mean? They don't know what's going on. They're like, one of these green building certifications, yeah, you must collect Manual J, and then they're like, well, what's it even mean? Is it just some numbers on a piece of paper, or what went into it? And so then, there's a lot of nefarious actors out there when it comes to free money, especially with incentives and stuff like that. So any little contractor that wanted to do the wrong thing and get the right amount of money for it was able to do that and still turn in paperwork until we set up these review programs. So it would be interesting to see ACCA take a more active interest into what is actually getting put into these things. I don't know what that would look like for you guys. That's a big undertaking, but it would be interesting.
And the struggle is, for every bad actor, there's a good contractor that says, I do have a special situation. When you said that, I was thinking of Charlie Munger. You show me the incentive, I'll show you the outcome. Give me a lot of money to install a larger system. Guess what's going to happen? But I was thinking about Allison Bales telling the story of a house that was in Colorado. And big mansion, a lot of glass, facing the mountain. And the sun shine bounced off the snow, and it was cold outside, and they were hot inside it, and they wanted to run the AC. Running the AC in 32-degree weather, or whatever it was, not a good idea. So there's some special things that you might need to do with ventilation to reduce the heat in the house. You need some strategy other than running your DX cooling system.
Design never stops being important. So that's one thing that there's a big point to be made. Like, you can do all the calculations in the world, but design is not a calculation. Okay. It is a design that serves the purpose of whatever someone's trying to achieve there. And I've been in situations, those are little microclimate stuff like that is crazy. Like, you get some lake effect in a place where there's not a lot of humidity, all of a sudden there's a lot of humidity. You know what I mean? Like, there's just different things that happen that you have to, as a designer, you have to be aware of. So I don't think one necessarily drives the other. Design is always paramount to whatever you're doing, for sure. Yeah.
It's a challenge. I think that there are going to be situations that was an example. I don't think that was necessarily the best example, but there are going to be.
I got the point. Like, there are some things where it makes a wrong thing right. You know what I mean? Like,
it needs to assess, to your point. Maybe it's the lake effect, or it's next to a large body of water, and so the relative humidity or the grains moisture difference might be different than what's specified in Manual J or on the ACCA climatic database.
And the good thing is ACCA gives you an out for that stuff. Like, everything that's in ACCA says.
But we want to give freedom, and that's a tough.
Even in the current versions of the manuals, though, it's like, okay, if you got a situation, document it. I mean, it's not that big of a deal. Like, if you have a big equipment load, because that's one of the things people always use is they'll put equipment in every room in the house and all these different loads that don't exist. But sometimes, and I go back in design review, I have found that nothing should surprise you. There is always going to sometimes be a reason for something. So we get these giant loads, and sometimes I'm like, can you send us the documentation on where this stuff's coming from? Crickets. Sometimes it's like, yeah, we already got it. Here's this theater thing this guy's using. Here's the AV room. Here's how many people's going to be in there. Like, the guys that have those situations, they pretty much know why they did what they did, and they can explain it, good. If there's no explanation for it, then it's probably some bullcrap, that you got to get out of there.
Well, and we also, in an effort to try and provide guidance, we want to design for one set of conditions. X temperature outside, 75 inside. Y temperature outside, 70 inside. So many people per occupants in the house based on the number of bedrooms. Well, what about my big July 4th party? What about the big whatever gathering I hold on a regular basis? Absolutely. That's extenuating. That's different. You do need to address that. But you need to start with, here's what your house needs 90% of the time. And if you've got 10% of these special situations, and it's usually a lot less than 10%, well, let's say 10% of the time I am having a large gathering, or I'm cooking out of my kitchen, or whatever the case may be, then you need to have a supplemental system. All right, let's add a mini split, or let's put in a supplemental system that can provide that extra capacity on Saturday night or Sunday morning, or whatever the case may be.
See, now you're getting into sales. You don't know that you're getting into sales. No, I'm serious, because like, this situation is very familiar to me that you're describing. So I worked in a LEED for Homes program where it was in a tax abatement, where a property tax abatement, where literally you could get $500,000 up to 15 years of the property tax abated if you built to LEED Platinum standards. So like, everybody was beating, that went on for 20 years in Cincinnati, Ohio. So everybody was beating down the doors to build these big giant McMansions that still complied with LEED. and also Energy Star. And there was a bunch of other requirements on them as well. ACCA Manual J is a part of all that. All the ACCA manuals are a part of all that. LEED requires them, Energy Star requires them. So we get down the road with these guys and they'd be like, well, this guy's going to have a party. And I'm like, I heard it so much that I Xeroxed the paragraph out of ACCA Manual J that actually says, because it's spelled out in there and it says literally the exact situation. You're going to have a guy that's going to say he wants to have a party. Here's what you should do. And the answer is what you said, supplemental heating and cooling. Here's why it's a sales failure, because I'm like, guys, it always comes out, they don't want to have to pay for that. Well, let me tell you something. If you're building $1.5 million house and you can't convince them that for the thing that they want to do, they need to pay a little bit extra for it to make it happen, then you're a shitty salesman. I don't care what you say. That is a you problem, not a ACCA Manual J or, anything else problem. There's a lot of guys that want to blame their sales failures on things that they think that they're told they have to do. And that's one thing that I hate. Let's separate sales failures from technical requirements, because they're two totally different things and two totally different conversations that intersect. All right, that's my soapbox on all
those sales failures. I think there's a lot of people with good intentions that want to install heat pumps and use heat pumps to heat the house all winter long. And I'm all for that if the heat pump can do that without drastically oversizing the cooling side of the system. Because oversized air conditioners have been a problem from day one.
Dude, I hate it. I hate the politicalization of it, and I hate the fact that
the contractors are going to put themselves in a position where they may have had the best of intentions, and it didn't turn out well for their customers, and it may impact them.
Well, here's the thing, man. Here's what literally happens to these guys, and it's not even like that. I feel bad for the contractors because they don't have the train. These things just get forced on them, and people, they say they can do what they want, but they don't have the training that is required to understand the situation that they're put in, because the stuff starts at the top. Everybody, whatever the administration is or whatever, wherever it comes from, the marketing starts pushing this whole electrification thing, the heat pump push, and it comes from a good place, I think. Some people want to save the planet. They feel like this is the way to do it. So I'm not talking against or for that. I'm just saying that is the situation that was created. So then these manufacturers are like, hey, this is the thing that everybody needs to be talking about. Then all of a sudden the manufacturers are telling these guys to sell heat pumps, but they don't talk to them about the house, and they don't talk to them about the right situation for a heat pump. And then it just becomes a one-shot solution where people are like, you need electrification, you need a heat pump, you need electrification, you need a heat pump. And I'm here to tell you, it's so funny that you bring this up, because Chris Hughes from TEC called me this morning. He's like, hey, I got something on my brain I need to itch, and it's about these cold weather heat pumps. And it's becoming a real issue because these heat pumps, the marketing was marketed like, you should do this, you should do this, you should do this. And one of the marketing is it's a two-way thing. It can heat and it can cool, which is technically true. But the thing that it can't do is also dehumidify if it's doing a really good job at heating in the cold weather. That's the one thing that you're not going to get, and you're just not. So I'm in a situation right now where I've been working inside of what started out as an EPA STAR grant for the city of Cincinnati. They were doing a study. So they basically had two different universities, and they're looking at 21 multifamily buildings in the historical over the Rhine district of Cincinnati. 7 of them they were doing nothing to. 7 of them they were weatherizing and putting a gas furnace in. And then 7 of them were full electrification. Well, these are 3-course brick, no insulation, historical buildings that you can't really do a lot to the windows because the Historical Society doesn't let you do them. So that most of them have old single pane with storms and stuff that rattle. It's just one of those old school buildings. So they hired our company to do the right to weatherization scope, to do all the load calculations, to do the equipment specification, to find contractors, like the whole 9 yards we were hired to do. Well, the challenge got down. There's so much to go, okay, like the mission is, it sounds simple, electrification. We're going to take care, they're going to put in, they already have electric water heaters, or they're putting them in, they're going to change the stoves all out to electric. The simple stuff they're going to take care of. But we need you to put heat pumps in these 100-year-old buildings. So the heat loads on these things, this is Cincinnati, Ohio. Your heating degree design temp is around 11 degrees, okay? And these loads are 100,000 BTU loads for 1,000 square foot or whatever. That's just what it is on the heating side.
No insulation, single pane, yeah.
Yeah. So number one, what heat pump fits that situation? The answer is none. No residential heat pump fits that situation, right? You could go to 2 heat pumps, but then you're doing crazy stuff to even get there in these little buildings to be able to put 2 heat pumps on them. So once we did the load calculation and the weatherization, like we're sliding in the home plate on 5 tons, you know what I mean? Like barely. Like, God, if we do all this stuff great and we air seal the hell out of these and we do blower doors, assisted air sealing in the units, and we put in some different storms than what's in there right now, you know, we spend all this money on weatherization, maybe, just maybe we can get these loads down to 5 tons. Okay, so that's 5 tons of heating. They have start out with 3 tons of cooling on the side, you know, because it's in a non-cooling dominated climate. And so we're starting out with 100,000 BTUs of heating, around 3 tons of cooling, maybe 4 on some of them. So then what happens is we shrink this load to get it down to 5 tons, but this cooling load goes all the way down 1.5 tons all of a sudden. You know what I mean? Wow. Because all the shit we did to get the heating load down, now it also affected the cooling load. So now we're at a diversity of 5 tons on a heating side versus 1.5 tons. So what do we do about that? The answer is there's not shit you can do about that. You know what I mean? Like you have to think of a better plan.
If you put in 2 and had, so one's providing the supplemental heat and then the other one's providing all the cooling, but other than that.
Right. And then here's the next kicker. So now A2L comes into play, right? Now you're telling all these guys, like this is another thing that people you can't even fathom it unless you've been involved in it. A2L in a residential home is probably okay. A2L in a multifamily building that is 100 years old is a freaking nightmare, okay? Because you have a code requirement to fire protect that line set from the living situation, which means a ventilated, insulated shaft either running through the building or on the outside of the building. In a historical district, to put anything on the outside of a building, you got to go through the most outrageous process to get it approved that you could even imagine. Like you got to get a consultant and all kinds of other garbage. So that's out immediately. So the next thing comes in is how do we get through 3-course brick, a insulated shaft through the whole entire building to run all these refrigerant lines up through and keep them protected. And I can tell you, it derailed the whole project. We've been at this for a year trying to get this stuff figured out. I mean, we got it. Right. We're done.
I was hoping you had the answer. I wanted to hear how it turned out.
Here, 2 things happened. One is you got to get somebody that knows something about something and has done this, because every state has a different answer for what's happening. You get an engineer in Indiana, they're going to tell you, oh, it's no problem. We got an exception from the state. We can do it. You get an engineer in Cincinnati, Ohio, or the whole state of Ohio, and they're going to tell you, you got to go to the most micro jurisdiction that you can find and ask what their answer is, because we don't have a state decision. And so then you got it for us. We're in the Hamilton County, city of Cincinnati. So city of Cincinnati is jurisdiction having authority. City of Cincinnati hasn't even thought this through at all. Like they don't have an answer for you. They want you to give them an answer. So then we had to go and talk to some architects, get a bunch of different opinions, do all this stuff. We finally found one architect that had got an exception in the county that they were in, not city of Cincinnati, but a different Ohio county, where they were allowed, because these are 4-story buildings. So instead of having to have a shaft all the way through, you can come from the top 2 floors and you come from the bottom 2 floors. And that way you don't need the shaft because you're not going through every unit with the A2L line. So then we were able to get that exception and write it in. But I mean, literally it took us 6 months to get there because nobody knows anything about any of this stuff. And it's all in the name of heat pumps, dude. You know, it's insane. And then it got to the point too in this project where because it's heat pumps and because of the nature of heat pumps and everything else, like this is also like 30-year-old ductwork. So we're like, if we're going to do this, like, and we're putting our name on it and this thing has to work and we're going to commission it, then we know for a fact that you can't use the ductwork that's in there. You got to redesign the ductwork around the heat pump, or else you're going to have some other problems that we can get into in the whole training or whatever. But like, there's problems that are going to exist from that. So then that was another thing, is like we were going back and through design reviews trying to get the ductwork. So finally the researchers are like, enough of this shit. They're like, either give us a different solution or we're killing the project. So I said, the solution was right in front of your face the whole time. All you had to do was ask, like dual fuel. Like we give the heat pump the light work, we give the furnace the heavy work. Okay. And so they're like, they like that because then they got another thing to compare. So for them, that's great. It's another set of data points. They're like, yes, that is the solution. But I told the team that I'm working with, the OTR team, which is like in between the research team and us, they have the people, the project managers. I told them, like, these people are winning. Like, dual fuel people won because they're going to have the best comfort. They're going to have the cheapest bills. Like, Cincinnati, Ohio is a natural gas market, and Duke, which is the cheapest gas in the whole entire country. So, like, these people are going to get the most. When it's right for the heat pump to work, it's going to be taking care of all that light temperature work, and then boom, the gas kicks in. You don't spend a dime extra. You actually earn money on that situation once you get below $1 CCF and all that stuff. So it's just a better situation. The point is, like, you can't have these one-shot back pocket solutions for anything in HVAC because it just doesn't work that way. Like, it just does not work that way.
So, real quick, I think that there are some manufacturers that are pushing hard, but I would think that it's a combination, right? I think there's probably some territory managers from some distributors representing some manufacturers. And sometimes the manufacturer gets a bad rep when maybe it's a one-off distributor that may not fully understand all of the things that you just so eloquently stated. And I think there are a lot of distributors that have a lot of good, strong, skilled, technically competent territory managers out there and other technical support fellas, but it doesn't take very many bad apples and everybody gets a bad reputation.
Well, I'll give some guys a shout out right now. Like, these guys, the Habagger Corporation, there's guys in Cincinnati, Ohio. Like, I went to them with this project and I'm like, here's what I'm trying to do. One thing that happened is Carrier had they published some bad data at first on these crossovers. So it looked like this thing could go all the way from the turn down on it is insane. Like the published turn down on the crossover, which is a Medea base with Carrier controls on it, was at 5 tons. It could turn down to under 1.5 tons. That's insane. Nothing has that capacity. But when I got down the road with them, has that much variation in it. When I got down the road with them, they're like, that's one thermostat, that one controller that can do that. We're not even selling it with that controller. We'd rather see you 24-volt interface it. And he's like, and then there's some things we can do on each end and they jumped into the project with me and they helped me figure out the best way to really use their equipment in the situation we were trying to use it in. And I will say that if you know what you're doing with that particular piece of equipment, there is some really cool things that you can do on either end of it. And when I say either end, I'm saying the outdoor unit and the indoor unit, and some adjustments that can be made that can allow you to really let that thing dehumidify and get the most juice for the squeeze on the heating end of it too. There are some adjustments. If the manufacturer reps know what they're doing, they can come out and do there's stuff inside the air handler that can be done. There's a lot of manipulation that can be done that can make it work right.
Instructions, or is this some secret?
No, I mean, I don't. Maybe it is published in there, but the stuff that these guys did, I don't know that it is because they in Florida. My brothers, this is anecdotal. This is pure anecdotal. Okay, I don't want this to be taken out of context. Like, I'm not a Carrier rep. This is not information that I'm giving out as a Carrier. Yeah, but this is just my experience with this equipment. My brother works for a Carrier dealer, and the biggest one in Melbourne, Florida. And those guys, they had a bunch of problems in the beginning with those crossovers too. They weren't dehumidifying right. They were ready to quit. They're like, they're getting spiffed out a ridiculous spiff on those things for the past 2 years because they were trying to get people buying them. So they're getting spiffed to sell them, but they were ready to give up the spiff. They're like, man, this is not worth it. Our customers hate these things.
Right.
So the rep said, hey, let me come out. And it's not Habagger. They have a different distributor down there, but he said, let me come out. Let me try to see what I can do. He did the same thing. He adjusted it for them. Now those things, that's one of their best selling items now from a dehumidification standpoint. Those inverters will drag the air. Now they are in a better situation than Cincinnati, Ohio, because they don't have heating loads to worry about. Okay. So on the heat pump side, it don't really matter to them.
Right.
Yeah. It doesn't matter to them what it's doing on the heat pump side, because whatever it's doing, it's probably going to be good enough. You know what I mean? So that
that's
part
you do a load. Yep.
Yeah. In Cincinnati, you got that mixed climate, so it's a biatch to deal with sometimes. You got to really consider things on both sides of the fence there. So
I'm really
design's paramount, but I
this
think
equipment that can dehumidify, because I've heard.
Yeah, I think that a lot of it can. My point is saying I think there's some brands out there. Like, I think a lot of these pieces of equipment, if you know what you're doing. This is why I like equipment, education is so important. Whoever you can grab onto that knows about the equipment that you sell, you should get in whatever group you can and understand it, because there are going to be things that can be done with any of these pieces of equipment. If you know what you're doing, you can fine tune them. You even got guys like Tim out there. They has the Hot Rod Boss, he's doing some different type of tuning up. But there is simple installation details that are being missed on these things that can allow people to make them function a lot better than they are.
Dig. Don't settle for, no, you can't do that. It sounds like if you get to the right people, there may be a solution for your piece of equipment.
I think
maybe not.
I think that's some of it is. I think the problem is you got to know what's what. There's sometimes when there's nothing you can do about it, the equipment's not going to run because the house is so well insulated. Right. And then that's a different problem. You need a solution for when that thing's not running versus something that it's going to do that you can affect on it while it is running. There's just knowing what playground you're in is a big deal for sure. So, all right. Fun. So great soapbox there. Let's jump into ACCA QI because I know that's something that you want to talk about. You guys want to promote that. I want to help you promote it. So explain to the audience what that is, how it fits into what we were just talking about and everything else.
Well, it's the other end of the equation, right? So you have to do a good design. In the middle, you've got the actual work. I'm setting the equipment. I tie it in. I start it up. I make sure that it's operating correctly. And then I commission it. I get those benchmarks. Is it actually performing like it should? I'm expecting this amount of air. Am I processing this amount of air? I'm expecting this low amount of duct leakage. Maybe you're testing the duct system and confirming it is as tight as we expected. And then refrigerant charge and even the electrical. I remember Richard Dean telling me a story that he installed one of the new, whatever brand he was selling, high-speed units, and they installed it and did a great job on it. And the customer called back and said, it's not working. And it was the last house on the last rural outpost of this particular electrical where the transformer was. And they were under voltage. And so it's pretty rare, but if you're getting the right voltage and the right amp draws from the equipment operation, documenting all of that, measuring what's going on when the air comes in and when it's leaving, is the system performing as it should, all of those aspects are captured or are the things that we're looking for in a quality installation. We prefer design, the equipment, and then the distribution system if there is one. If I've got a ductless system, don't have to worry about leakage, don't have to worry about necessarily airflow. That's a tricky one, and this is anecdotal, but from my anecdotal experience, getting the proper airflow is not a problem on a new piece of equipment. It's very rare that a brand new, pick your brand, ductless system doesn't deliver the design airflow. Yeah, if it's installed positionally correct, if it's too close to a ceiling, maybe sometimes there can be problems. But if you've got the right clearances from the manufacturer calls out, the equipment's going to perform.
And as long as you understand the throw, that's the biggest airflow flaw that people have with that thing is throw.
And that gets as much deducted as it does ductless. But those are the things that we're interested in for a quality installation, checking on the other end.
So there's two different pieces to that? Am I right in saying that? Two different, is QI and then something else? Or
So it's a challenge to eat the whole enchilada. If you had Beard Meats Food, he would have sometimes struggle eating the whole whatever eating challenge it is. The design work up front, I think a lot of contractors do. Installing the equipment correctly and then measuring how it's performing. I think that's a little smaller majority or a smaller segment. But the duct system, testing duct leakage, it takes some time. It takes effort. It takes a commitment. You've got to want to do that, and it's not always baked in to that price you just quoted for a replacement. Air balancing. And air balancing is more important on the new home. Are we getting the right amount of air to the right place? But those aspects, design, the equipment, the distribution, can be a tough load to carry. And so with Measure Quick, we said, can we get the equipment right? Is it the right size? Are we basing it on a load calculation? Maybe not. But are we at least making sure it operates correctly? Let's clear that hurdle first. We have the proper airflow. The refrigerant charge is correct because we've checked the airflow. And then there's some other electrical measurements we want to capture. If it's a fuel-fired appliance, I want to make sure it's on rate. Are we combusting correctly or not? And so those are the aspects that we're focusing on with our verified equipment operation. So if you do soup to nuts and you look at the whole system, that's verified system performance, because that's the whole system. But if it's just the equipment, is the equipment operating correctly? We'll recognize that. We'll award a certificate for equipment that is operating correctly. And that's the effort. I'll tell the quick story, Jeremy. Energy Star came to us about 2010 and said, hey, we want you to be the gatekeeper and only let good contractors in. And that's such a wide, are they running a good operation? Are they taking care of their people? Are they good marketing? Are they got clean, or are they technically competent? Or both. Hopefully it's the whole package. Whatever it was, we knew we didn't have that insight. We weren't capable of doing that. So what we said we could do is we can make sure they're licensed, we can make sure they have current insurance, we can give them an orientation, some basic training about Energy Star and about what we're expecting from them, and then we can provide some oversight. And the oversight was going to be two-part. We were going to have some ResNet HERS raters at the time do some field evaluation, and the ACCA was going to come along, and about 10% of our accredited contractors a year, we rifle through the paperwork and look at their operation. And so that is how we started, which was essentially make sure they can clear a few hurdles at the beginning, and then I promise to do good work. And then we're kind of coming in after the fact, and if we find that they're not doing good work, we take corrective action as necessary. But we'd rather say, I can show you I did good work. I don't have to say I promise, I can just prove it. And so quality installation, we would like to continue to accredit contractors who promise to do good work, but we want to see them migrate toward I can prove I do good work. And so our accreditation and our quality installation are going through another transition, both moving those contractors over as well as re-envisioning what that means. If I'm not an accredited contractor, but I'm doing good work, I want to say, let's go ahead and give you accreditation. Let's give you that recognition. You need to prove your license. You need to have insurance. You need to do all those things. But if you're doing good work, that's what we want. And so I would rather recognize those good contractors and provide a way for Jeremy, if his mom needs a system and she's in somewhere else, either he can call around and say, hey, do you know anybody in Shreveport, Louisiana, or in Savannah, Georgia, or Augusta, Georgia, wherever the case may be. Oh, yeah, call up this company. Or, yeah, just go to the ACCA, go to their directory, and if they're on that list, that's a quality contractor. That's someone who's going to be able to technically deliver a high-performing system or equipment.
Are you guys, is QI listed on betterhvac.org as one of those?
It is not. We've been trying to get, we need to get out of, we got to figure out that how to work with Bill and Kevin on that.
Yep, Kevin, that's good.
That's something, that's something we need to figure out.
That's a good one. That's a good one just to get, they're pushing people to that website to find good contractors. So if guys could say, hey, we ACCA QI or however it works, that would be awesome to see on there. For sure. Well, we're running up on our hour. We had a good conversation. Anything else you want to tell anybody before we jump?
Tons. We'll have to do this again, Jeremy. That's a lot of fun. Thank you for having me.
Yeah, I loved it. Great conversation. We can get into some. When's Emmanuel D's coming up soon for their update?
Emmanuel D is coming up soon. We just finished an audit of our American National Standard procedures. Just finished that, and I believe today or tomorrow the final paperwork will be submitted. Alex Meany's been working on the user's guide, so we'll have a new standard with new illustrations, not just the little microscopic version, something you can actually see.
Well, I cannot wait. I mean, half that, there's so many fittings in there that just don't even exist anymore. I cannot wait till that thing gets cleaned up.
And that's another project on my to-do list is we need to do some research and testing on real boots. I've heard them called PI boots. We call them
Some other rear duct system and stuff like that, using those 3-inch ducts and those home run systems. Maybe mention it. I mean, they have their own way of designing and it complies with Manual D, but it'd be nice to just see some mention of those different systems in there. It does. Yeah, they do. Yep. Yeah. Yeah. Cool. All right, Wes. Thank you very much. I'll talk to you soon. I hope I see you at the next conference, whatever that ends up being. Who knows? All right. I'll see you, man. Thank you.